Well, worked so good last time. Here's another crucible full of IC chips ready to be pyrolyzed in my foundry. So, I'll put them down in the foundry and heat them up until they're glowing orange hot, and cook off all the plastic, all of the organic, all of the volatile compounds, and just basically turn them into ash so they can be crushed up easily and get the gold bond wires out. So let me get this started, and I'll show you what the process looks like. Okay, the foundry's lit. It's starting to heat up. Ooh, it's getting hot fast. This process probably take about 25 or 30 minutes based on how long it took last time. Let me put the lid on to keep the heat in. That'll speed things up. Now, it's going to smoke pretty bad as it heats up, but eventually it'll get so hot that the smoke coming out will, when it mixes with the air, will ignite and reburn, and the smoke will disappear. I may end up, if I do this a lot, I may end up putting a reburning stack on top of the foundry to allow the air to mix with the smoke and provide a pilot light so it'll start burning earlier. We'll see. Because it does stink a little bit, I have to say. But I think it stinks less than wet ashing with sulfuric acid, which I've tried too. But boy, does that stink too. It's been going for maybe 5 or 10 minutes now, maybe closer to 10 minutes. It smoked quite a bit at first, but now the gases coming out are hot enough that they ignite once they mix with air. So the pyrolyzed products from the plastic in there they're being vaporized and mixing with air as they come out the vent hole and catching fire. So there's no more smoke now. So it's getting really hot in there. Looks like the crucible's just starting to glow. So the chips are on their way to being well pyrolyzed. So this will probably take another 10 or 15 minutes, and it'll probably be done. Ooh-wee, that's hot. It's been about another 10 minutes and everything inside is glowing bright orange. I'm gonna turn the heat down because my goal here is not to melt anything. And this foundry will melt metal. So I don't want to get it that hot. I just want to pyrolyze everything fully. So I just turned the gas pressure down some. So it should cool down a little bit. I just want to pyrolyze everything thoroughly. I noticed that some of the stuff in the center of the mass of the last group I didn't get fully pyrolyzed. So I think what I'll do is I'll just, like I said, turn the heat down a little bit and let it cook a little while longer than I did the last group, just to make sure everything's fully pyrolyzed. Well, it's been running at lower pressure for a few minutes now. In fact, I got the pressure turned so low the burner's struggling to stay lit. You can hear it chugging away there. So it didn't so much cool off when I did that, it's just stopped getting hotter. So I think everything's probably pretty well pyrolyzed in there by now. And certainly if I turn the heat off, the residual heat will finish the job. So I'm just gonna shut it down. There, okay, the gas is off, so it's just residual heat in there now. It's not really showing up very well on the camera, but those chips are hot. So this is going to take hours and hours to cool down. I'm going to leave the lid on for now to keep the heat in, just in case there's anything that's not fully pyrolyzed. I see a few little curls of smoke coming up out of there, so there's probably still some organic matter in there. But so I'll leave the lid on for now to keep the heat in, and then I'll take the lid off later and let them cool down. so I can actually handle them. But it's going to take hours and hours. In fact, it may be a project for another day to actually crush them up and sieve them. Alrighty, it's been maybe not quite an hour since I turned the heat off. I left the lid on until just now. Took the lid off to have a look. Look at how white those are. Those are totally pyrolyzed. I mean, remember what they looked like before I put them in here. And this is what they look like now. They're totally white. And man, there's still a lot of heat coming out of there. It's going to take hours before these cool down. Now that I got the lid off, hours before I can handle them. So I'll just let them sit and cool down. And like I said, I may not get to doing anything with them today because it's just going to take a long time for them to cool off. But we'll see what we get once they're cooled down. Alright, it's been a few hours and everything's cooled down, and I found I actually have a little bit of time, so I got this old $5 blender. I don't even know if I paid $5 for it at a yard sale. So, and then here's the chips I incinerated this morning. I just dump them all right in here. Alright. And I guess the question on everyone's lips now is, will it blend? Well, let's see. Yes, it blends. It's not happy about it, but it's blending. There's a fine powder coming out at the top, so it's working. Alright, I'm going to put the phone down and shake it up a little. Okay, I shook it up. I'm going to blend it some more. Okay, that's probably pretty good for a preliminary blend. Let me get it sieved out. I'm going to do an initial sieve through my... ooh, look at the dust. That is fine. I probably should be wearing a mask. Okay. Note to self, get a mask. I'm going to do an initial sieve through this kitchen sieve here. Oh, what have we here? Well, no wonder it was complaining. Look at that big chunk of copper. Huh. I should look closer at the chips I was incinerating. I just dumped a bunch of them in there. There was one that had a big copper heat sink. Well, that's a pretty good blender. Yeah, the blades don't look any the worse for wear for beating up this copper heat sink. Okay. Alright. Now most of that is probably metal. But there's a lot of black stuff there, ash, plastic, whatever. I'm going to return it to the blender and blend it some more. Okay, I returned the stuff in the sieve back to the blender. I'll process it again. I just wanted to give you a look at this. Now this is the initial sieving. I see a lot of wires in there. Most of them are probably copper. I see a few on top that could be gold, but most of it's probably copper. What I'm going to do is I'm going to sieve this through finer and finer mesh screens until I get to... I'm going to aim for -40 unless it gets clogged up really bad with those gold wires. But I'm sure it'll go through at least -30. And anything that doesn't go through will get returned to the blender for further processing. So after blending, sieving, reblending ad infinitum, I've got a gold pan full of -40 debris from the from that crucible full of chips. And here's all the stuff that wouldn't go through the sieve. It all seems to be metal. I mean, there's the big copper heat sink that I somehow didn't notice I was on a chip I threw in there. But these are all bits of metal, now badly mangled by the blender. It's all metal, it seems to be. Now, in spite of the fact that I sieved it to -40, there's still metal in here. And if I run my magnet through it, some of it's steel too. This is a really powerful magnet, so it collects a lot of stuff. Now, let me drop it in here, and then pull it up again, and drop it again, and pull it up again, so I'm not taking too much powder with me when I take the metal out. Do this a few times, and try to just get the metal out and leave the powder behind. Now, I see more metal in here that the magnet isn't picking up, so it's probably copper wires. Small copper wires that made it through the sieve, the 40 mesh sieve. And every once in a while, I'll see a little tiny shiny gold wire. But most of them are going to be really small. Oh, there's some more. Pick them up, drop them a couple of times to separate the powder from them, and put them over here in the metal container. So that's probably about as much as I'm going to do. I'm not getting much more out. So next step is to pan, and I'm just going to pan to try and remove, you know, the fluffy stuff. The bulk of this is just ash that doesn't contain any metals. It's just, you know, ash chips. So if you do panning right and you classify it well like I have, the gold's going to sink to the bottom. It's going to be in the corner of the pan. And you can get rid of the bulk of the barren material without losing gold. So I have seen people do these incredibly elaborate procedures on ash chips to try and get rid of the ashes and not lose the gold. And I'm like, if you guys just knew how to pan, you wouldn't have to go through all this. So it's not that hard. You know, I've been panning for most of my adult life out on the creeks of the West, so I can pan and not lose gold. So that'll be the next step. The hardest part about panning this stuff, and you know, I'll be perfectly honest about it, it is a problem, is that this material is incredibly hydrophobic. It does not want to mix with water. If you put water in this pan, all this stuff's just going to float on top of the water. It's not going to mix with it. Making this initial slurry is the hard part, and that's pretty darn difficult. You need something in your water that's going to break the surface tension, maybe a couple drops of Dawn or some jet dry or something, and you're just going to have to stir it and stir it and stir it and get your hands dirty and get splashed with nastiness and stir it until you get a good slurry going. And then once you've got a slurry, you can actually pan it. But this stuff here, it just does not want to mix with water. Not initially anyway, it's just too hydrophobic. But if you've got the surfactants in the water, you can eventually get a slurry. And I'll show you that when I get around to it. Okay, to make the slurry in advance of panning it, I've returned the fine powder back into the blender. I'm going to add some water to it. And I'm going to add a little bit of jet dry to it. Not much, just a few drops. I don't want to create foam, I just want to break the surface tension so that this very hydrophobic material will mix with the water and create a slurry. So, just a couple drops. That's probably a little too much, actually. Came out faster than I was expecting. Alright, got the lid on. Set on low. I'm just going to pulse it. Gently and slowly. Alright, let's have a look and see what we got. Well, looks like a slurry to me. I'll tell you what, if you tried to just wet that stuff in the pan, it would have been just incredibly difficult, because that's what I tried the first time I did this. I just dumped it in a pan and tried to pan it like it was plaster concentrates or something, and it all just wanted to float. It didn't want to mix with the water. So there we have a nice slurry for panning. There we go. I used my rinse bottle over here to rinse everything out of the blender into the pan. So all the materials here in the pan, ready for panning. Alright, I panned away probably about 90% of the material. I did it off camera. I've got tutorials on how to gold pan online, and there's a million others. It's dirt simple if you practice it a little bit. It's not hard. So this crescent of stuff over here, don't get excited. That's not all gold. That's mostly copper. There's a lot of copper in here. A lot of copper wire. But there is, right up against the corner of the pan, there's a nice crescent of gold underneath that copper. So I'm not going to try panning anymore. The separating the gold from the copper is not going to be easy. I just wanted to get rid of the bulk of the ash. And what I'm going to do is I'm going to transfer this to a beaker, and I'm going to treat it with nitric acid and dissolve away all the base metals. The copper, any iron that made it through, anything else that's left there, and just get rid of those. Then I'll rinse the residue, and then I'll dissolve the gold that's left. I'll dissolve that, either in aqua regia or with uriatic acid and bleach. It doesn't matter. It's fine gold. It'll dissolve real quick either way. So that's the plan. Alright, I've transferred the slurry left over from panning to this beaker, and rinsed it a couple of times with some distilled water to make sure there's no chlorine in there. And I'm going to add a little bit more distilled water. Just 50 milliliters or so, I suppose, to start with. I'm going to dissolve the base metals in there, mostly copper. I'm going to dissolve them in nitric acid. The problem is I don't have any nitric acid. But what I do have is some sodium nitrate and some sulfuric acid drain opener. If I combine them in here, I'm going to have nitric acid, and that copper will dissolve. So that's what I'm going to do. I'm going to put a couple spoonfuls of sodium nitrate in there. I'm going to top it off with a healthy splash of or two of the sulfuric acid drain opener, stir it around, and I think we'll see a pretty interesting reaction happen. Okay, there's the sodium nitrate in there, the prills. Here goes the acid, a little bit at a time. Look at those orange fumes. Oh my goodness, it looks like we got us some nitric acid. And stand up wind here. Oh yeah, look at her foam. Glad I used a big beaker. I was afraid foamage might happen, maybe even foam over. So that's going to dissolve all that copper that made it through the screen. And then once that copper's all dissolved, I'll rinse this stuff again with distilled water a couple times to get the copper salts out of it. Then I'll dissolve the gold out of it, and it'll be nice clean gold. That's the plan anyway. Everything's been going to plan so far. Hopefully it'll keep doing so. So I got to stay upwind of this. I got to get my fume hood finished. I'm building one. So I definitely need that fume hood finished. So I'll make tracks away from this mess for now, and I'll come back and check on it in a while. And if it needs another shot of acid and nitrate, I'll give it one until keep that up until all the copper's dissolved. Be back. Okay, so it's been about an hour. I came out and gave it another shot of acid and nitrate, and when the reaction stopped, and it revived it a little bit again, but there wasn't much. I put a little extra water in it too to give the metal salts something to dissolve in, and that kind of revived it a little bit, but it died down again after a while, and I think it's done. I think all of the copper and any other base metals that were in there have been dissolved. Pretty blue color to it. I hope that's showing up on the camera. So that's probably copper nitrate, some copper sulfate in there. Got ashy stuff and gold on the bottom. Everything else should be in solution. So I'm gonna decant this liquid into my stock pot and wash the remains with distilled water, and then see if I can get the gold to dissolve. My goodness, ashing the chips makes a heck of a mess. My workbench is trashed. I'm glad I was wearing my painting clothes while I did it, because I got pretty dirty too. Alright, it's time to dissolve whatever gold is in here. So I'm going to add a little bit of muriatic acid to it. I don't know how much nitrate's left in there, because I did a pretty thorough job of rinsing it. I wanted to get the base metal salts out of there, so there may not be much nitrate left in there. So what I think I'm going to do is there's probably not very much gold in there, so I'm probably going to do about maybe 50 to 100 milliliters of acid in there. And if I don't see any kind of reaction, maybe I'll just add a couple of squirts of bleach to it, and that should be enough to dissolve the gold. Well, I just dumped in about 100 milliliters of muriatic acid, and I'll tell you what, there is a reaction going on. There is a pretty good reaction going on, so there must be some nitrate left in there. The solution's already turning yellow. I mean, it's been like 30 seconds. I see some fizzing and bubbling away in there. So there must be some residual nitrate in there. So it looks like we got some aqua regia going on here, and it looks like maybe there's some gold going into solution too, because the solution is turning yellow. So that's a good thing. We'll just let this cook for a while. Okay, I decided to put it on the heat. You know, it's like 90 out here, summer in Florida, but I know this reaction works better at about 70 C, so I've got it on the hot plate, and I'll warm it up to about 70 C, and we'll see how it goes. Alright, it's been about 10-15 minutes. I put it on the heat, nothing much was happening, so I added a little bit of extra sodium nitrate to it, and I'll tell you what, that ignited a real reaction. So, and I just did a stannous chloride test, so I've definitely got gold going into solution, so this is good. So I got poor man's aqua regia working in here, dissolving the gold. So we'll just let this cook for a while, then it'll be time to filter and precipitate. Alright, the reaction seems to have run its course. Unfortunately, it's getting late, and I've got some things I've got to do, so I'm just going to turn this off, let it cool off, and it probably won't be till tomorrow till I get around to filtering it and precipitating however much gold's in there. So, project for another day. This took longer than I expected. Alright guys, it's the next morning, and I'm ready to filter and drop the gold in this solution. We had terrible storms all night long, just torrential rain, thunder, lightning, wind, terrible. And it got actually quite chilly too, unusually chilly for this time of year. So I turned the heat on in this solution just to warm it up a little bit so that when I denox it, I'll be able to see the reaction happening with the urea. You can't really tell. If you put a little urea in a cold solution, you can't really tell if there's anything going on. I actually put a little sticky note on it last night to remind me to denox it, because I didn't do that before I shut down for the night. So let me do that. I got some urea here somewhere. Let me put a little of that in and see what happens. Okay, here we go with some urea. Oh yeah, bit of a reaction. Just going to add urea until there's no more reaction. There's more nitric in there than I thought. Ah, it's slowing down. Okay. That looks pretty good. Okay, good. Next, I'm going to filter it. And it's a pretty dirty solution. There's still a lot of ashy stuff down in the bottom of it. It's pretty black and nasty. So I'm doing my usual trick of I got some cotton balls stuffed in the bottom of the funnel to sort of give it super filtration. It'll be slow, but that's okay. I'm not in a big hurry. I want a clean solution. I don't want a fast solution. So let me wet the filter down a little bit. And start filtering. Gonna try to leave the black, nasty, ashy stuff, as much of it as possible, in the bottom of the beaker until the end, just so it doesn't clog up the filtration and slow it down any more than necessary. Yeah, that's the stuff I'm talking about down there. So yep, a few drops at a time coming through. And what I will do is after I get all this filtered through, I will wash down the filter paper and the cotton balls until the liquid runs clear, to get all of the gold out of the filter, because I doubt there is a whole lot of gold in this solution. I want to get every bit of it. I don't want to leave any on the filters. Alright, the liquid's all filtered. Yeah, the nastiness is left behind in the filter up here and in the cotton balls. I'll add them to my gold filter collection. The liquid, well, it's nice and clear. Can't complain about the clarity of it. Not sure about the color. It's a little green. So there's a little bit of impurity in there, I'm sure. But hopefully there's some gold. So I'm gonna transfer it back to the beaker it came from. I just cleaned the beaker. Transfer it back into that and warm it up a little bit before I do the precipitation. I seem to have better luck with precipitating from a warm solution. So I'm going to warm it up. Like I said, it's a little chilly this morning, unseasonably chilly after those bad storms last night. So I will transfer it over and warm it up. All right, guys, the solution is warmed up. I just did a stannous test on it, and I got a good strong reaction. I did one earlier when the gold was first starting to dissolve, and it was a little weak, but I knew it hadn't all dissolved into solution yet. So now I've done another one, so I've got a good strong reaction there. So there's some gold in solution here. I'm still not thrilled with the color. It's a little greenish, a little bit off from the pure chloroauric acid color. But hey, you know, I'm not gonna reject it for that. I'll precipitate out the gold, and if it seems dirty, I'll just reprecipitate it. So we're ready for precipitation. So here we go with some sodium metabisulfite. As usual, I'm just going to be lazy and dump the powder in. It's usually a pretty vigorous reaction with a hot liquid like this. Little bit of a color change. Let me give it some more. Oh, now that's more of a dramatic color change. That's the kind of color change we're looking for. That's the color of gold precipitating out of solution. Lovely. All right, so I'll just let that sit and settle for a while. Keep it clean. And we'll see what we get. See what color the solution looks like after settling. I'll give it another stannous chloride test just to make sure it got all the gold out of solution. Well, it's been maybe 30 minutes, and well, there's a respectable amount of gold that's come out of solution down there. The solution's still a little cloudy. I'll probably let it sit overnight before I try to get the gold out of it and clean it up. But yeah, that's a respectable amount of gold, considering I processed maybe a pound of ICs. I should have weighed them. I'll weigh them next time. But yeah, for a pound of ICs, that's not too bad, I suppose. So I'm going to just let it sit and precipitate. Let it sit overnight. Make sure I get everything out. Okay, so here's all the gold I got out of that. About a pound of IC chips. And next time I do this, I'm going to be a lot more scientific about it. I'm actually going to weigh up the chips and figure out a yield then. Still, you know, 0.3 grams from a pound doesn't seem like much for processing e-waste, I suppose. But hey, if it was gold ore, this would be like the richest ore on Earth. So, and actually, sometimes the scale flickers up to 0.4. So I need a scale that goes to another decimal place. This scale really sucks. So the one thing I really like about processing IC chips is the system I have now. I can process a lot of them quickly. You know, if I get an early start in the morning, I can go through probably several runs through the foundry to pyrolyze them, and then after that, the crushing and the sieving and the panning goes really quickly. So I can combine multiple groups together after they cool from the foundry in the blender and blend them and sieve them. And so I could probably process 3-4 pounds a day easily of IC chips. Now, I need to figure out which chips give the best yield. That was one thing I did not do on this. Like I said, I need to be more scientific about it. This was a big mixed run of different types of IC chips. There were a lot of old chips from like the 70s and 80s in there. 40-pin dual inline plastic chips. There were Z80s, there were 8080s, there were all sorts of support chips, and I don't think there was much gold in those. I think there was a lot of packaging for not much gold in those. But there were also a lot of more modern flat packs, and there were a lot of small surface mount chips, and there were a lot of RAM chips in there, modern RAM chips. And there's a lot less packaging on those, and I suspect the gold to packaging ratio is much better on those. So I think what I need to do is I need to sort chips in the future and see, you know, where I get the best yield from, and maybe concentrate on those, especially if I'm going to purchase them from people to reprocess them. I want to make sure that I'm getting the most bang for my buck. So, but I'm actually pleasantly surprised at you know, how much gold I got from that pound of chips. And I think if I'm more selective about what I process in the future, I can get a lot more gold out of them. So it's dirty gold. It's ugly. I think there was some carryover of some base metals. And after precipitation, the liquid had this sickly green color to it. Still, I did a stannous chloride test. There was no gold left in solution, so I got it all out. But something carried over. It was really nasty, sickly green color. And the gold is not the fluffy, you know, brick red stuff I've been getting the last few drops. It came out as almost black, very, very, very fine powder that did not want to settle out of solution for the longest time. I lost some of it on the filter I was using, but I don't think it was enough to make a difference on the scale. It's just a tiny little bit of gold caught on the filter. I'll just put that with my gold filters collection. So I suspect probably, you know, some copper, some iron, maybe some tin, which would be, you know, tin is a big one for making gold not want to drop out nicely. So probably what I need to do, I suspect, is just do better acid leaching on the concentrates from the panning before I try to dissolve the gold, and see if I can get out, you know, more of the base metals before I dissolve the gold. So I think some base metals carried over. But on the whole, I'm happy, and I've got lots more chips to process, and like I said, in the future, I'll be much more systematic, scientific about it, and figure out what works best, And thanks for watching.